Two variables can move together for a very long time. That co-movement is not a mechanism, it is a statistical pattern. A model built on that pattern encodes what has been observed, not what causes what. When the underlying driver shifts, the pattern breaks. The model had no mechanism to hold on to. Correlation is structural only in the sense that it is real in the data. It is not structural in the sense that it will survive a change in the system. Conditioning restricts attention to a filtered part of the state space. The dynamics within that filtered region are unchanged. Conditional probability is a mathematical ratio over observed outcomes. It does not alter how the system transitions from one state to the next. What you observe and what you control are different operations on the system. One is selection. The other is a change of the rules. When you intervene, you sever a variable from whatever was producing it. You replace its update rule with an external assignment. The resulting trajectory is generated by a different set of rules. That trajectory is not the same as the trajectory you would observe conditional on seeing that value. Conditioning leaves the dynamics intact. Intervention replaces part of them. The numbers are different. A confounder is a hidden state variable driving both the input and the output simultaneously. It creates the appearance of a direct connection where none exists. The observed co-movement traces the confounder's path, not the path between input and output. Conditioning on the input does not block the confounder's separate path to the output. The indirect channel remains open. The model built on this association will fail as soon as the confounder changes course. Conditioning selects a group of cases that already were shaped by the confounder. That group is not a random sample from the system. It is a sample filtered by the same process that produced the bias. An intervention assigns the input to everyone, regardless of the confounder. Those two operations produce different outcome distributions. Selection carries confounding forward. Assignment severs it. A correlation model has no state variables and no update rules. It cannot represent what happens when you change the system. It cannot survive a shift in the distribution that generated the data. When the confounder changes, the observed pattern collapses, because there was no mechanism underneath it. Correlation is purely descriptive. It does not carry information about what causes what. And that is exactly where it breaks.